So I'm going to tell you a little bit about some work that a former student of mine and I have done. I've got a lot of material, so we'll sort of pick and choose, and we'll cover as much as we can. Okay, so I'm going to start by just talking a little bit about why blogs are interesting, why we would want to study them in the first place. We'll talk a little bit about tagging, which I'm sure you all have seen in some form or another, and a little background, maybe information retrieval in 5 minutes, to explain to you how we can use tags and we can use textual content to try to categorize documents. And then I'll talk about how we've used clustering algorithms to try to do a little bit better job of this. So probably you all know what blogs are, right? Yes, okay, good. They obviously come in a lot of different flavors, from political blogs like Daily Kos, tech blogs, personal blogs. They're everywhere. And they're very exciting things. From an information retrieval standpoint, or from a data management standpoint, they're challenging to work with because of the scale. Okay, so Technorati is a company that indexes blogs for search engines. They have their own custom search engine. Currently, this number is out of date. I think it's over 100 million now that they index. And the amount of new data that's generated is really overwhelming. Over 1.6 million new posts a day. It's a real challenge for conventional search engines like Google to work with because things are updated so frequently. Blogs come up and down all the time, and so it's really just even managing all the data is tricky. So the question is, well, is there other software that can be used or developed to help maintain and organize this sort of thing? Again, the standard search engine approach, Google's getting a little better at it, but it doesn't really deal with recency very well. Most of Google's standard search algorithms look at what's called prestige or PageRank. Maybe you guys have heard about that. PageRank doesn't tell me about that blog post that came up 5 minutes ago about an earthquake that happened. Right? I need something else for that. It doesn't tell me about importance within a community as well. Something that's globally important by PageRank may not be very important to a specialized community that's interested in a particular topic. Okay, so why would you care about blogs? What sort of things would you want to ask? You might want to say, what's this blog about? I like blogs about, new technology, for example. Is this blog about that? Find me blogs about that. I like this particular blog. I don't know why, but it's good. Find me more like that. That's a question I ask all the time. I've been reading these 5 blogs a lot, and they're pretty good. I want to find more that are like this. And I maybe can't describe it easily in a keyword search, what it is that I like about it. Advertisers and marketing people are very interested in questions like, what do bloggers think about the iPad? Right? It turns out that back in the day, the way market research worked was before the iPad rolled out or right after it rolled out, you would spend all this time and money calling people and doing customer surveys and those sorts of things to try to find out, do people like it or not? What do they like or don't like? And it was very hard to get at that data. It was very expensive. Now, the great news is people, if I'm a marketing person at least, the great news is people are giving me this data for free by just going on their blog or going on a forum or going on some news group and posting about the iPad. Why doesn't this have Flash, etc. Whatever your complaint is. Why is there no USB port? But you got to get that information out. And there's way too much of it to have a human being do it. So you'd like to, in an automated way, figure out this post is about the iPad and extract what they call the sentiment. They like it, they don't like it. Here's why. Okay, so we might be interested more in kind of macro level questions. What blogs are most linked to? Who's most widely read? Politicians and people in the political arena are interested in this. If they want to get a message out, say about the new healthcare bill, they might want to know what bloggers are being widely read, who's the most influential, right? How can they shape their message best? Who should they talk to get the new point across, or the new talking points out? What are some communities that are out there, right? I might want to know, even just from a graph theoretic point of view, it's interesting theoretically to know that there are little islands of people that are talking to each other. Again, advertisers and manufacturers very interested in this question. Consumers of blogs are interested. Turns out natural language researchers really care about looking at this stuff too. Back in the 70s and 80s, if you did natural language processing, that is, having computers process text and understand meaning, it was actually really hard to get your hands on a lot of data because it wasn't digitized. Now we sort of have the opposite problem. There's drinking from a fire hose. There's so much data out there, and blogs are a great place of data that's written by normal humans, right? Not Shakespeare, not the encyclopedia, but data that actual real-life people have written. And Shakespeare's a real-life person, but you know what I'm trying to say. We might want to try to use that sort of writing to extract mood, classify language, translate, those sorts of things. But we got to figure out how to manage all this data first. Make sense? Okay, so that kind of sets the stage. Why do we care about blogs? A lot of big questions in there. What we're looking at is a more specific question, which has to do with tagging. And you guys have probably all seen or used tags in one place or another. If you've used Flickr, or you've used YouTube, if you've used Delicious. How many of you guys use Delicious? Okay, Delicious is great. Delicious is a collaborative bookmark sharing site. So I see some awesome new website about the iPad, and I want to share it with Professor Ledeen. Well, I could just email him the URL, right? But then he's got to deal with his email, and he doesn't, he throws all my email in the spam bucket, so I don't want to do that. Maybe what I can do is just share it on Delicious, and then he can subscribe to my RSS feed. And then every time I add a new bookmark, he can just see what I'm looking at. And then I can tag them. So and a tag is just a keyword that I assign to it. This is about the iPad. This is about Sonoma State. This is about San Francisco, right? What's great about tags, so here's a tag cloud from Delicious. You maybe have seen this before. So they're all just single keywords, right? And some of them are real words, like programming or news. Some of them are technology terms, like OS X or Linux or Mac. Some of them are somewhere in the middle, Web 2.0. And so Delicious just organizes them alphabetically, and larger tags are the more important ones. More important meaning more widely used. Sound good? Nothing too scary there, I don't think. So tags are great because they're very easy to learn. Right? My mom can understand how to tag. And my mom is about the most computer illiterate person there is. All you got to do is you say, what's this about? And people start assigning keywords. Right? So you don't need to know anything about logic. You don't need to know about database schema. You don't need to know about representational issues. You just say, put some keywords on this, and people can get that. They're very popular. That turns out to be a big issue in the web, is if a lot of people are already using this, then it has extra value. Right? We call it the network effect. And it turns out that with the web, the great way to get your data annotated is to have your users do it for you. Right? The web and blogs are way too big to have some company sit down or pay somebody to do it, but if you can get users to annotate your data for you, you might have a shot at scaling. Sound good? Okay, but they have some bad news. Right? Of course, there's no free lunch. Tags do not have a lot of representational power. How many of you guys have taken a logic class? Okay. How many remember what you learned? Okay, some. Okay, so tags are what we would call propositional entities. Okay? They're equivalent to propositional logic. So, in other words, we can't indicate relations between things. I can't say that all articles that are tagged with Linux are also about computers, for example. Right? I can't say that all articles about Buffy the Vampire Slayer are also about television. That would be a general specific relationship. We just don't have that representational power. I can't say opposites, right? I can't say good and bad are opposite things. Like and dislike are opposite things. All I can do is assign strings to articles, basically. They're solely syntactic. In other words, there's no meaning behind a tag. It's just a string that gets attached to a document. So you're vulnerable to all the sorts of problems that you come up with in any sort of information retrieval problem. Synonyms, right? So I tag an article cat and you tag it kitten. How do we know those are the same thing? Misspellings are huge, right? Word endings, right? So I tag it cat and you tag it cats. Those are just different strings, right? So those are two different tags from a tag system's point of view, even though we as humans know that they mean the same thing. The visualization tools, I'm not so impressed with the tag cloud, with this thing. It seems like you could do better than alphabetical by size. That is not very manageable to me. And tag cloud only shows popularity, right? That maybe popularity is interesting, maybe it's not. So the good news is tags are easy to use. You can jump in right away and start doing it. The bad news is they're sort of limited in how they let you manage information. Okay, so like all good research, this started out as an argument in the hallway. I was arguing with another professor at USF about whether tagging was good or not. And I said, no, it's just a waste of time. It's so silly. You can't say anything interesting. And he said, well, but no, it's good because it's very easy and people can use it. And so I said, well, all right, let's see if we can prove this. So we started out by just trying to conduct this experiment of are tags valuable? Okay. And so we started by getting some data from Technorati, mostly because they have a nice, easy-to-use API. They have a web service API that uses REST. If you've played with REST at all, it's great. You just send them a URL as a query, and you get XML back, and you can parse that. It's free. At the time, we had a student USF working for Technorati, so I could just call him, Ryan, what's going on here? Why is this broken? And he would fix it right away, which was good. And then you can get all these blogs back. And then once you've got all these blogs, you can do all the standard sorts of things you would do in information retrieval. Okay. So what we wanted to know was, are tags useful? And we decided that was too broad a question. That didn't really mean anything. So we said, well, let's be a little more specific, and let's say, what sorts of tasks are tags good at, and what are they bad at? So I always tell students, if they say, this language is good and this language is bad, or this algorithm is good and this algorithm is bad, you're being too simplistic. Right? Everything is good for some things and bad for some things. Right? So it's not that Python is better than Java. They have different strengths and weaknesses. So I said, all right, well, let's see if we can figure out what tags do well and what they do poorly. And so you can look at it as either a search task or what's called a browsing task. So a search task would be, I'm interested in some articles about the iPad. If I put iPad into Technorati, I should get back articles that are tagged with iPad. Are they truly about the iPad? And a browsing task would be, I want to find some things that I like. I don't have a specific need. I'm just I'm bored and I don't want to grade papers, and so I'm going to surf the web for a while. Oh, look, here's some iPad articles. Are they really interesting to me? Are they really similar? And then if they're not, maybe there's an automated way that we can suggest better tags to a user. Because it turns out that even though you can get users to tag your data for you, nobody likes to do it. Right? We're all lazy. We want to have a program do it for us. So this data is about 5 years old. I'm not sure if you can read it or not from the back. But this is the top 250 tags on Technorati. And it should give you an idea of what you're up against when you're trying to manage this. The first thing that we noticed right away is that a lot of the tags are very general. Right? They're things like politics or general or history or hobby. Right? So we didn't really expect them to be categorizing articles that were very similar to each other. We thought they would be broad topics. Lots of synonyms and related concepts. We knew that would be a problem right away. And this is a common criticism that comes up with tagging is, should I tag something video or videos or movies? Right? If you don't have all your users agree on which tag to use, well, then you get this sort of dissemination. There's even a deeper argument, is cinema and movies the same thing? I would say yes. People who are real cinephiles would say, no, that's very different. The Seventh Seal is cinema, Die Hard is movies, because cinema has some artistic quality to it. Sorry if you like Die Hard, I don't mean to insult that. Another thing to notice is we have multiple languages in here. Right? So here's Poemas, which is Spanish, Santé Peut-être, which is French, and I took out all the Chinese and the Arabic and the Hindi text. So that's going to make our life hard. And it may not even be that the tag is the same language as the article we're trying to look at. Often the article's in multiple languages. Lots of spam and jargon, right? So here's acne news and weight loss. Those are spammers. A lot of jargon as well, right? So iPod is in here someplace. OS 10 is in here. Those aren't real words. In other words, they aren't in the dictionary. Okay, so that's going to make it challenging for us too. VoIP is in here. RSS is in here. And then there's a lot of tags that just are not very good. Right? So stuff is in here as a tag. I don't think that tells me anything about what the article is about. Or etc. Or everything. Right? So what you see here, why is this in here? Because people use tagging for two different purposes. Some people use tagging to share their data with their friends. And so then they pick a label that their friends will like. Right? Like radio or like music. Some people use tagging as a way to keep their own stuff straight. Right? So if you use Gmail and you use the tagging in there, you're probably not sharing your email with everybody else. You're just trying to keep your information organized. And so stuff might make a lot of sense to you. That's where I put all this junk that I don't know what else to do with it. But it doesn't tell anything to other people. So part of the problem is that people are using tags for these two different cross purposes. And so we had to try to tease that out. Okay, so again, those of you who've taken propositional logic or have taken a logic class, tags are just propositional entities. So in other words, we can't talk about relationships between tags. We can't quantify over tags. We don't have any class relationship, subclass, superclass. We don't have any other relations we can specify. We can just say an article has a tag. So if you've taken AI, how many of you guys have taken the AI class? You probably learned that you run up against a lot of problems right away with propositional logic as a representational scheme. It's great, but it makes it hard to say complicated things. A common thing that comes up is people will try to tag an article with San Francisco. Well, the taggers typically split on white space by default, and so you get one tag that says San and one that says Francisco. That wasn't what they meant to say, right? Or San Francisco and California. Those get split into two separate tags. There's no relationship between those two. So maybe they're not as intuitive as we think. In other words, maybe people think that they're doing a great job if they tag something San Francisco space California, but really they're just making things hard on themselves. Actually, the common convention is just to put an underline here instead, but you have to know what you're doing to do that. Okay, so what we started with is, can tags be helpful as a means of aiding search? Okay, so, and we said that was still too broad, too general. So we nailed it down, and we said, okay, well, let's ask, do they make it easier to find things I'm interested in? And do articles that share tags, are they really very similar? Now, this felt like something that we could actually answer. Okay, are tags good? Way too messy. This one we could actually test. That's a hypothesis. Okay, so I'm going to try to explain information retrieval in 5 minutes. So very fast, high moving, high level. Don't panic too much if you don't get every little detail. Okay. So what we need is we need a way to take an article A and an article B and say how similar they are. Okay, well, we could have a human being read the two of them and maybe assign some score, but that's very subjective, and we have a lot of them. And even poor grad students won't do that. So what we said was, well, we need to just look at the words. And luckily, it turns out the information retrieval community has been doing this for a long time. And so these ideas have been around for a long time. They're very well tested. Any of you used Lucene? So Lucene does this. Lucene is a Java-based indexer and search tool. So what you do is you treat the document as what's called a bag of words. In other words, you take it, to keep it simple, we split on spaces, so we have a bunch of tokens, right? And then we just count how often each token occurs. You got to be a little more clever than that. You got to deal with punctuation and things like that. But just to keep it easy, we split on space, and we count how often each word occurs. Okay? So we throw away a lot of information that might be helpful here, right? We throw away all the order, we throw away sentence structure, we throw away frequency, or not frequency, proximity, right? But we want to keep it manageable because we have a lot of documents to work with. So that's our trade-off, is we can scale if we give up a lot of information. Okay, but what we learn from that is what's called the frequency distribution of each word. So you take tens of thousands of blogs, and you just count how often each word occurs in the whole collection. And that tells you, not surprisingly, words like a, and, the, he, she, it are common. Words like aardvark are less common. Right? iPad, maybe, maybe not. So this is what's sometimes called a Unigram model. Okay, that's just a fancy way of saying we're counting single tokens. We could count pairs of tokens. That's what's called a bigram model. What's good about this is it's fast, and it scales very well. We can scale to millions of documents, and that's just poor little old us at USF. Google can do this with billions of documents. We could do more structural analysis, but we would run into scaling problems much faster. So far, so good? Okay, so jump in if you have questions, by the way. So you can think of this. How many of you guys have taken linear algebra? I know, all these things that you thought you got to forget, I'm going to talk about. We can think of these words as a vector. Okay, they're really an n-dimensional vector, or this bag of words, where n is the number of possible words that occur in the lexicon. Okay, the lexicon is a collection of all the words. But most of those dimensions are 0, because most documents don't contain every single word in the English language. They just contain a subset. Okay. So the good news is, and this is the other secret I always tell students, when you don't know how to solve something, turn it into a problem you do know how to solve, and then solve that problem. So we don't know how to compare two documents, but we do know how to compare two vectors. So we take this problem we didn't understand, and we turn it into a problem we do understand, which is linear algebra, which is just comparing two vectors, and now this is well known. We know how to do this. Okay, what we actually, we want to scale a little bit, and this is why I asked you if you knew about TF-IDF. TF-IDF, and I'm not going to go into it because we don't have time, is just a weighting scheme that gives extra weight to words that occur rarely in the language, but commonly in a document. So if I had a document about aardvarks, again, the word aardvark is very rare, but if it occurred 10 times in the document, that would be a strong clue that it's really about aardvarks, and I should put a lot of weight on that. The word this occurs everywhere, right? And so the word this occurring 10 times in a document doesn't really tell me anything. So I should weight that very low, very small, right? So TF-IDF is a standardized weighting scheme for doing this. In the interest of time, I won't go through the math. But once we have that, so now we have a vector for each document in our collection. Okay? And we've weighted the dimensions of each vector according to how important we think those words are. Now we can calculate the cosine of the angle between them. And cosine has this nice property that, so what's the cosine of 0? 1. Okay, you're about to say that, I know. So if two vectors are identical, they share all the exact same characteristics, all the exact same words, their cosine will be 0. They're right on top of each other. Or I'm sorry, the cosine will be 1. The angle is 0. So what if it's 90 degrees, or pi over 2? What's the cosine of that? 0. See, it says here on the slide. So what that means is, if two documents are completely different from each other, they share nothing in common, well, the vectors are going to look like this. So here's a picture. So the vectors, one will be here and one will be here. This angle is pi over 2, or 90 degrees. The cosine of that is 0. So we get this nice scale where 0 means documents are completely different from each other. 1 means documents are completely identical. We like that, right? We can bound it nicely. So here's a simple example. Let's say we had document 1, and it had 2 instances of cat and 1 instance of dog. Document 2 had 1 cat and 2 dog. And dog is on this axis and cat is on this axis. We would see here's these vectors, and then we would measure the cosine of the angle between them. And the more similar they are, the closer they are together. Make sense? Again, don't get too wrapped up in the math. That's not really the issue here. The issue is that we have this nice metric that's pretty easy to compute that will tell us how similar two documents are. Sound good? Okay. So, now that we've got that, we can actually do some experiments. So what we wanted to know was, how similar are all the documents in a group that were tagged with the same tag? And we've got this cosine similarity metric that will tell us how similar two documents are. So we went off and we got the top 350 tags from Technorati. Okay? And then for each of those tags, we got the 250 most recent blog entries that had that tag. And we just kind of picked these numbers out of a hat because that was how much we could manage to get done in a reasonable amount of time. So we convert them to a vector, like I just told you about, and then we measure what's called pairwise cosine similarity. So in other words, we take everything from set 1, and we compare document 1 to document 2, and document 1 to document 3, and document 1 to 4, 1 to 5, and so on. Then 2 to 3, 2 to 4, 2 to 5, and we just average that. Okay, so that, you could also treat this as a cluster and find the centroid. That would be fine as well. But pairwise cosine similarity seems to work pretty well. So what we wanted to know was all the documents that were tagged with the iPad, on average, how close are they to each other? And so the null hypothesis is that tags don't tell you anything. So in other words, if we pick random articles and measure how close they are, and we pick articles tagged with iPad and measure how close they are, we should get the same number. If it turns out that the iPad articles are closer than the random articles, well then iPad does tell you something about the articles. They're more similar than random articles. That was our first experiment. So the other thing we thought was going to happen, actually, was that common tags, we thought it would go like this. We thought it would slope upward, and that common tags would not have much similarity, and rare tags would have a lot. Because, if somebody tagging an article with aardvark, that's pretty specific. Stuff, not so much. It turned out that wasn't the case. So this graph shows popularity. So this is the most popular tag, and down there is the 350 most popular tag. And then this is cosine similarity on the y-axis. So there's this little spike here. This is around games and gaming, actually. But for the most part, it's flat, which kind of surprised us. And it's not very high. So we looked at that and we said, okay, well, so the average cosine similarity is about 0.25. So the first question you have to ask yourself is that good or bad? I don't know. So we said, all right, well, let's go and get some random articles. We'll just shuffle up all our blog articles, throw away all the tags, and see how close these randomized clusters are. And you get this picture. It's on the left here. And you can see that the average ones are about 0.15, 0.16. So the take-home message here is that tagging gave users a little bit to work with. Articles that were tagged with the same tag were a little more similar than random articles, but it wasn't great. Right? So we said, all right, well, how good could you do? What if we had human beings group articles by similarity? So we went off to Google News, which actually doesn't have human beings do it, but it has very smart people coming up with good algorithms, and it was a nice source of data. So we went off to Google News, and we grabbed documents from different clusters. They've at least been checked by a human to make sure that they're reasonable. And we said, well, how close are those clusters? What could we really expect to get if everybody had done this tagging correctly? And that's about 0.4. So in other words, tagging winds you up someplace between random and what a technique like Google News can use. Okay, so it's okay, but it's not great. Seems like there's some room for improvement. We could definitely get up to where Google News is going. Sound good? Okay, so that told us something. So we said, well, how can this get better? Why 0.25 doesn't seem very good? So we said, well, maybe people aren't very good at doing this. You know, and they don't really extract the right tags. They put things that are too broad or too general. So what we did then to test that is we said, well, let's find the three most important, or the three most information-containing words from each article and use those as tags. And so our hypothesis is, don't make users tag the article. You could do this automatically. You could just run a program over your blog post, extract the most relevant words, and use those as the tags. Maybe it's better, and it's certainly easier. And so the graph you get here is like this. So what we found was that by doing that, you get more clusters for sure, but you get smaller clusters. So if you're interested in doing search, this approach works really well. If all I want is articles about the iPad, then this works really well. I get very tightly focused clusters. It's not such a great result if I'm interested in browsing. If I just want articles about technology in general, well, now I've got to go visit more clusters. So what I found was that by extracting information actually from the article itself, rather than letting users do it, you could create these smaller groups. So that was good news. So far, so good? Okay. So that was nice, but you still have this other explosion in the number of tags that you have to work with. And there's this relational problem. Remember I said that there's no way to relate San Francisco to California. Right? So all the articles that are clustered San Francisco and all the articles that are clustered California are in two different groups. Really, what I'd like to be able to do is, if I want articles about California, you should give me the articles about San Francisco too. Probably, right? Because San Francisco is in California. Or if I want articles about Apple, you should probably give me the articles that are tagged OS 10. Right? There's some relationship there. So what we said was, well, let's see if we can figure out what these relationships between tags are in an automated way. Tagging doesn't really give users the ability to explain these relationships themselves, but maybe we can infer it using machine learning. And that would be a first step to bootstrapping what's called an ontology. So again, those of you who've taken AI, an ontology, it would be sort of the other way around of trying to represent all these articles. Rather than just assigning keywords with no semantic content, we would design a complex knowledge base that explained that California is a state in the United States and that San Francisco is a city in California. And so articles that were tagged San Francisco might be about California, or would be about California as well, and that California and Nevada are next to each other and so on, and we could reason about all that. You can do a lot more with it, but it's very hard and it's difficult to scale. It requires a lot of person hours to really build this kind of thing. So we thought, well, maybe we can take a first cut at it by just learning a hierarchy of tags. And then maybe you could use that to bootstrap into something better later on. And so we took another well-known algorithm from the IR community called Agglomerative Clustering and used that. And the way it works is pretty simple. We're going to try to build a tree. Okay, so we start out with these groups. right? So we've got, here's our articles tagged iPod, here's our articles tagged Apple, here's our ones tagged Windows 7, here's our ones tagged computers, and so on. And we want to build some sort of representation where we know that iPod and Apple are related, and Windows and Bill Gates are related, for example, and then they're both related at some higher level in a thing called computers. We want to try to infer that automatically. So what we do is we start with our tag clusters, okay, and then just like before, we use cosine similarity to figure out which two clusters are the closest together. So we've got to look through every single cluster pairwise. So this is a little bit computationally demanding, but that's fine. We can do this offline. So we take cluster 1 and cluster 2, we figure out how far apart their centroids are. We take cluster 1 and cluster 3, how far apart are their centroids. Cluster 2 and cluster 3, and so on, until we compute everybody. We take the two closest ones, whatever they are, and we remove them, and we replace them with sort of an abstract cluster. That's the concept that represents both of those. I'll show you a picture of this in just a second. And then we go again. Now we've got t-1 clusters. And we say, what are the two closest clusters? We take them out, and we replace them with the cluster that, so we're kind of building a tree from the bottom up. At the end, we'll have one concept at the top, which is sort of the thing concept, or the root level concept. Okay, so we wind up, hopefully, with a picture that looks like this. This is what's called a dendrogram. Right? So these two were deemed to be very similar, and so they get grouped together into a slightly larger concept. And then they got paired with this concept here and this concept here. So you wind up with this sort of structure. Okay, this is actually just a small piece of it. The whole thing is very big because, remember, we had 350 tags. Okay, so the good news was that we actually saw some grouping based on concepts that made sense to people. Right? So this one is all home and garden here. So I'm not sure if you guys can read it or not, but so garden and ponds got grouped together, and then wine and cheese somehow got grouped in with that. So I guess you drink wine when you're out in the garden. Foreign policy and legislation got grouped together. Car insurance and auto insurance. Here is prescription and weight loss and health tips. More interesting to me, those are all pretty straightforward because they all are conceptually or have similar subject. More interesting was down here, the tag my day and the tag mood and the tag feelings and the tag about me all wound up being very similar. So this is where we're crawling LiveJournal over here. They're all sort of people talking about themselves. And so, they may not really share a lot of the same keywords, but the sentiment is the same in here. And so you've sort of found this more generic thematic concept. That, to me, was really interesting that we were able to pull that out. The bad news was that only looking at vocabulary the way that we're doing can give you some errors. So, for example, politics and games wound up being grouped very closely together because they share a lot of the same words. They talk about scores and winning and losing and victors. Right? So even though they're talking about very different things, because all we're doing is this syntactic analysis, we're not really analyzing content, you really run into problems with that sort of thing. A more subtle problem was that users don't do that great a job of tagging. This took us a while to figure out. We thought this was a bug for the longest time. It turned out that dairy and diary wound up being really closely related. What do cows have to do with, teenage girls in high school? I don't understand it. And eventually we went through and looked at our code, what's going on, I don't get it. And eventually we realized it was just people misspelling diary. But because we're just looking at these things as syntactic entities, we're not looking at the meaning of that word, we're really susceptible to that kind of problem. So what that told us, the take-home lesson was that you're only as good as your users will give you data for. And so that suggests that having automated tags extracted really helps you out because you're less susceptible then to misspellings and weird word choices that a human user might have. Or at least checking. So one thing that we've done based on this is we built some tools to both suggest tags, tell people maybe you want this other tag instead. I think maybe you want diary instead of dairy because it seems like you're writing about your day. Show me other articles that use the same tag. The idea here would be to sort of promote common tag usage. So if everybody writing about the iPad is using the tag iPad instead of Apple, well, you can suggest to a user, this might be more effective for you. And then, in theory at least, if I write about the iPad a lot, I probably want to read about it. And so we can find other articles, not only that have the iPad tag, but other tags that are similar in the sense that they're in the same subgraph of the hierarchy. Does that make sense?
How do you fight against the fact that if somebody has a misspelling like that, it may end up giving a high TF-IDF score to that word because it's...
That's you can't completely. I mean, that's a challenge, I think. So if they've misspelled diary as some other word that will have a really high TF-IDF score, with our approach, you can't really do anything about it, other than you hope that maybe the rest of the document's content weighs that out. A more clever approach might be to compare the tag to the content and look for co-occurrence and say, boy, you said dairy, but none of the other words in your document have anything to do with cows at all, so I think this is a mistake. We don't do that right now, but that would be a road that you could go down. You could use a Bayesian classifier probably to do that, predict how likely is it that this tag goes with this content. That might be a future direction. So to wrap up, I think I'm actually on time. Yay. What's interesting about tags is that they're so widely used. There's all this data out there that makes it really attractive to look at. It's sort of a hard problem, and it's one that's got a real application to it. So we like that. They seem to be here to stay. I lost the argument about are tags useful or not. I was eventually convinced that they're useful because people are using them. But we like to find ways to make them more expressive without making it challenging for users. We can't expect users to learn first-order logic, probably. So we'd like to build automated tools that help people get some of the benefits of richer representations without forcing them to do a lot of work. And ideally, we'd like to be able to annotate data that humans haven't even looked at. And we've realized that users really need better tools to do this. And so that's where we're at right now. Also, we're trying to figure out other relationships. Subclass, superclass is only one. That's the easiest one to infer. But we'd like to infer things like owners and subjects and things like that. We're going to have to be a little more clever about how we cluster to do that, I think. We can do much better at document analysis, I think, than we do right now. TF-IDF is a pretty simplistic mechanism, but it's great because it's fast. And we're also working on how to visualize these things better. Like I said, I don't think the alphabetical list of words is all that great when I'm really trying to pick a good tag. So we're working at better methods for suggesting things. So that's where we're at right now. So I'll stop with that, and if you guys have any questions, I'd be happy to.
Back from your original sample set, where you have 350 tags and 50 documents related to that, are those single tag relations or multiple tag relations? Because it seems like that's like a separate sort of question. If you have a single tag relation, you're getting a correlation with cosine of 0.25 or so. How much do you get when you have a two-tag correlation?
Yeah, that's a good question. We didn't look at that. So the way the Technorati API works is you say, here's my tag, cat. And it says, here's all the documents that are tagged with cat. Now, some of those may have also been tagged with dog, right? And so we just sort of left that out. That would be a next step, I think, is documents that share 2 tags or 3 tags. And there's kind of different directions to go in there, I think. You could try to look at relationships between tags and tease all that out and say, are those articles really more similar if it's cat and kitten versus cat and dog? We just didn't go down that road, but that's a great point, I think. Basically, we convinced ourselves that we needed to do more to make tagging work better, and then we kind of went down the hierarchical clustering road from there. Other questions? Okay, well, thanks for your time. I have a couple papers about this on my website. You're welcome to come check it out or send me an email if you want to know more about it. Great, thanks.